So what are we doing?
We're doing chapter 5, yep, our notes. 5-1. And to help us, we have a little reference sheet for chapter 5. Now, this is going to terrify you, but remember, we're not even doing most of the chapter. So, this is the same reference sheet I use for everybody. So we're just going to kind of highlight the ones that matter to us. And there really aren't very many on here that matter to us. We're not going to do any of the identities except we have to know that tangent equals sine over cosine. So we use that one, because we'll start by that one. And then we use what are called the Pythagorean identities, which are the first ones right here. Sine squared plus cosine squared is 1. That group of 3, right here where my finger is pointing, that group of 3 right there has 1s in it. And really, other than things that you already have memorized, like secant is reciprocal of cosine, that's not on here because you already have that memorized. Secant is reciprocal of cosine, right? The rest of this sheet, you don't even really need to worry about, but keep it close to you because there might be something on there that will help you do a problem. So, what am I doing here in these problems? It looks very strange, and as one of the kids in the honors class said, this is for there are no numbers. Yep, this section is all about the functions. So, let's see what we're supposed to do when it says simplify. Just looking at that, do you have any thoughts about anything you could do? Anything you could do? Well, we can't add them. This would be like having, in an algebra class, this would be like having m cubed plus m squared. This is like, sine is like one variable, and cosine is like another variable. These, you would never add these, right? They're not like terms. What would you do with something like that? What could you do? Take out an m. So in my problem, obviously I don't have m's, what am I going to take out? What do they both have?
Sine.
So I'm going to take out a sine. I'm going to factor it out. I'm going to factor out sine x. What will I have left if I take out a sine x? Well, what will I have left here if I take out a sine x? Sine squared x. And when we have powers on our trig functions, sine squared, do you understand why I don't write it this way? Why would that be confusing?
Because that would be x squared.
It looks like x is being squared, right? You could do this, but that's extra writing. If you write that, that's perfectly fine. But most people always just put the squared after the sign because it's the sign we are squaring. This and this mean the same thing, and it doesn't matter to me which way you do it. This is the way I will always do it. All right, so I've taken out my sine, so I'm left with sine squared. What am I left with here? Cosine squared plus cosine squared. Now, once you look at your reference sheet, and the variable is different, I'm using x's here, and it's theta on the worksheet, on the reference sheet. But what does it say right here where my finger's pointing right there? What does it say about? What's it say? Sine squared plus cosine squared equals 1. Well, wait a minute. Isn't that what I have right here? So this is 1. I have my sine, but the parentheses is just 1. So, the answer is just sine. Sine times 1, just sine. Direction said simplify. That's what I started with. Isn't this a whole lot easier than what I started with? Yep. And how did we do that? We simply factored. And why did we factor? Well, we really couldn't do anything else. We noticed we had something in common. And when you have something in common, you should try to factor it out. GCF. Just like you always have. All right, let's look at the next one. Okay. Gotta do something. So just look at the problem and just think about what would you do if they were like regular numbers and stuff? What would you do, April? Foil it out. Isn't this going to be a foil? All right, so here we go. We're going to foil. So we have secant squared, because we're doing secant times secant. And then we have on the outside, we have secant times -1, so negative secant. And then inside, regular FOIL, kids, like you've always done, FOIL. So inside is give me positive secant, and my last, give me -1. Again, somebody might say, how did she know to do that? Look at the problem and do what you would do if this was Algebra 1. You got two parentheses times each other, FOIL it, seems like a good option. Now, what happens when I FOIL? What, anything good there? These guys disappear, right? So I have secant squared -1 over sine squared. Now, this is where things get a little bit tricky. This is where now, I mean, I would consider this all just basic algebra. But now we gotta use some trigonometry. I want you to look back at your reference sheet and look right in that group where we were looking before, right there where my finger is. And is there a line there, one of those, we call them identities, is there one that includes, it's not gonna look exactly like this, but does it include a secant squared and a 1?
Yeah.
Yes. What does it actually say? What does that one actually say on the paper?
1 plus tangent squared.
1 plus tangent squared equals secant squared. Isn't that what it says? Now, why am I looking at that one? Because I have a secant squared and a 1. And on my reference sheet, there's a formula that has a secant squared and a 1 in it, and it looks like that. Now, I'm going to take -1 on both sides. If I do that, if I subtract 1 from both sides, what does it say now? What does it say now if I subtract the 1 from both sides? Tangent squared equals secant squared -1. Why is that good news?
Tan equals sine over cosine.
Yeah, I'm gonna go there in a second, but first I'm gonna do this. What's secant squared -1? Tangent squared. So now my problem, I'm gonna write my problem as tangent squared over sine squared. All right, this is day 1. We gotta fight our way through it, kids. Step 1, FOIL. Step 2, simplify. Step 3, and this is the tricky one, recognize that secant squared -1 is special. secant squared minus 1 is tangent squared. So this can become a tangent squared. Now, if you want, on your reference sheet, if you want to write this on your reference sheet, it's exactly the same as what's written there, but it's in a different order, you absolutely can. On test day, you'll be given a new reference sheet, so I don't care what you write on here to help you as you go, but on test day, all that other stuff you write won't be there, but you're free to write it down. Now, Catherine says, tangent is sine over cosine. That's on your paper, I just handwrote it on there this morning. Tangent is sine over cosine. So we have sine squared over cosine squared over sine squared. Okay, so come back here where we are. Tangent, I'm rewriting as sine squared over cosine squared. It's squared. So it's sine over cosine squared. And then it's over the sine. Okay, you with me? So secant squared minus 1 became tangent squared. And tangent squared became sine over cosine. Now, this is a division problem, isn't it? So this is like sine squared over cosine squared divided by sine squared. This is just kind of a longhand way of writing this out. Isn't that the same as sine squared over cosine squared times 1 over sine squared? Because when I do a division, don't I multiply by the reciprocal? And what's happy about that? Well, these cancel. So after all this, what am I finally left with? Be careful, where's the cosine squared? On the bottom, is it 1 over cosine squared? That's in the bottom. So 1 over cosine squared is what's left. Full credit right there, perfectly done. Maybe a little extra if somebody recognizes. What do we know about 1 over cosine? What's 1 over cosine?
Isn't it -1?
No. No. What's the reciprocal of cosine? 1 over cosine is? Secant. So this is perfectly okay. But if you recognize that 1 over cosine is secant, that is even better. Okay, that's a doozy. I know what you're thinking. You're thinking there's no way I'll ever be able to do this by myself. And you're wrong. You will. We just have to practice, practice, practice. So let's look at the next one. Now I don't want anybody doing any crazy things. Let's just kind of look at it. This is a subtraction problem, right? And the things that I'm subtracting are both fractions. What do I do when I subtract fractions? Get a common denominator. My common denominator will have to be 1 minus sine and cosine, right? I need both parts for my common denominator. So this piece, right here, this piece needs a cosine. And of course, if I put 1 on the bottom, I need to put 1 on the top. And this piece needs the 1 minus sign. So we notice that we are subtracting fractions. We know that when we subtract fractions, we need a common denominator. That common denominator is that denominator and that denominator, both denominators. So this one, that denominator has to match this. So I needed to put a cosine here, and I needed to put a 1 minus sign here. Everybody still with me? Now, they both have the same denominator, so now I can put them together in one giant fraction. So what's my numerator? What happens here? These are multiplied. What does that equal? Cosine squared. Now, this one's a little trickier because that's a parentheses. So what am I going to have to do here in this multiplication?
Do both.
Distribute. So negative sine times 1 is just negative sine. Negative sine times negative sine, positive sine squared. So we figured out what our common denominator was, and then we just multiplied our pieces together. So we had cosine squared minus sine times 1 minus sine times negative sine. Everybody with me here? Now, when you get to my age, this problem, your little heart's just going to be fluttering right now. Because look what you have. You have a cosine squared plus a sine squared. What is cosine squared plus sine squared?
1.
It's 1. So my top, my numerator is just 1 minus sine, and my denominator is still 1 minus sine times cosine. Well, what do you notice about that? You can cancel. Now remember, you can't cancel pieces. Like I couldn't say this sign will cancel with this sign. You can't cancel pieces, but you can cancel whole quantities. Whole things will cancel. So what does that leave me with?
Cosine.
Be careful. Where is the cosine? The cosine is in the bottom. What's on the top? 1. Again, absolute full credit for that answer. But what do you know about 1 over cosine? It's getting started is the hardest part. So let's go back clear to the beginning. How did we get started? We saw we had 2 fractions being subtracted. So we did what we do when we subtract fractions. We got a common denominator. Okay? Number 4. Alright, so what do we got here? Cotangent over cosine. You know how there's always more than one way to do a problem, so I'm going to show you the way that makes sense to me. As long as you end up with the same answer, you can do it another way. But when I see something like this, I immediately want to write it longhand and say this means cotangent divided by cosine. Now, why do I want to do that? Well, what is cotangent? Look at your paper. You're not going to see it. But what you are gonna see is tangent is sine over cosine. What do we know about cotangent? Cotangent is the reciprocal of the tangent. So if tangent is sine over cosine, then what's cotangent? Cosine over sine. So I'm gonna write this as cosine over sine. If you wanna add that to your reference sheet, go right ahead. We need to know the reciprocals. That needs to be memorized. You need to know that cotangent is the reciprocal of tangent. So if tangent is sine over cosine, then cotangent is cosine over sine. Okay, now what's cosecant? We talked a lot about secant today, but we didn't really talk about cosecant. What's cosecant? Reciprocal of sine, 1 over sine. So cosecant is 1 over sine. Again, that is to be memorized. If you want to write it on your sheet, totally can, but you need to memorize it because you're going to get a new sheet on test day or quiz day, okay? Now, can you kind of see, now that I've done that, can you see why I like to write it longhand? Because I'm going to turn this division into a multiplication, and this is going to be sine over 1. Remember, Mrs. Field, keep, change, flip, keep, change, flip. This is just algebra. But what happens? That's a multiply problem. Now I'll make this times. That's a multiply problem. The signs cancel. And what are we left with? Cosine over 1, which is just cosine. So remember, your job is to simplify. So that's what happened. We just canceled and we're left with just cosine. Now, me having done that one, can you approach the next one exactly the same way? So can you start by writing it as, by the way, those thetas, if you would rather make those x's, you can. You can always change the variable. So if you don't like the thetas, which I used in number 5, that's a theta, make it an x if that's easier for you. So I'm going to write this out longhand. So cosecant divided by secant. And then I have to remember, and this has to be in my memory bank. I mean, like I said, I don't care if you write it on your sheet now, but you need to memorize this. What is cosecant? Cosecant is reciprocal of sine. So this is going to be 1 over sine. Is that okay? What is secant? Reciprocal of cosine, so 1 over cosine. So now I have another division problem, so I'll make that 1 over sine times cosine over 1. Now nothing cancels. What do I get when I multiply those? What's on top? Cosine. What's on the bottom? Okay, now wait a minute. Cosine over sine. That would be cotangent. Because on your paper, we have sine over cosine. You get that, guys? Sine over cosine is tangent. So cosine over sine would be cotangent. I don't know, this is so fun. Some of you are yawning. I'm like, what? Okay, number 6. will have to do something like this on our test. So let's be real careful with this one. Probably the single most important identity in trigonometry is the one that says sine squared plus cosine squared is 1. It's called the fundamental trigonometric identity. You can rearrange that just like we rearranged earlier with our secant formula, our secant tangent formula. This can be rearranged. So for example, if I subtracted sine squared from both sides, what would my equation say? This is what's written on the paper. That will always be written on the paper. But if I want to rearrange some things, if I want to subtract that sine squared, what does it say now? Cosine squared equals 1 minus sine squared. Which means every time I see a cosine squared, I can replace it with 1 minus sine squared. So if I don't like having a cosine squared, I can just change it into a 1 minus sine squared. Now, why would I do that? Well, again, I'm going to take you back to algebra class with Mrs. Field. I want you to think about when you had problems like this. And she said, factor this. How did you do that? How does that factor? M plus 3 and minus 3. We call it the difference of squares. So if we had m squared minus 16, that would be m minus 4m plus 4. And if we had p squared minus 1, p plus 1, p minus 1, right? We could do that all day. Guys, that's exactly what you have right here. You have a square minus a square. So that factors. How do you think that factors? The numerator, how do you think that? 1 minus sine squared. What are those factors going to look like? One's going to be plus, one's going to be minus. What are they going to be? 1 sine. Yep, that's exactly right. 1 minus sine, 1 plus sine. That's how it factors. Sine squared is just that. It's sine squared. Just like 9 is 3 squared. Well, what do you notice? What happens? They cancel. And the answer is simply 1 plus sine. I know it's mind-blowing. It'll get easier, I promise it'll get easier. Let's talk a little bit about this one more there, because I know this is going to be something like this. It's going to be a test question. What was the first thing I did? I changed my cosine squared into 1 minus sine squared. Now, kids, I want you to think about why I would do that. My job is to simplify. Right now, with that looking like that, does anything cancel? Does anything factor? That's not a squared, so that bottom doesn't factor. So basically, I am stuck. If I don't change something, I'm stuck. There's nothing to do. Anytime I have a squared function, I can change it into something else. cosine squared is 1 minus sine squared. Earlier today, tangent squared was secant squared minus 1. They can all be changed, and they're right there in the list. Right there. They can all be changed. Once I made the change, then I have to notice that's the difference of squares. And that happens in a lot, probably half the problems we do. We're gonna have a difference of squares. And we're gonna factor it. And hopefully cancel it. Alright, a couple more. Number 7. Gotta get started, so just throw something out there. What could we do? Can we collect like terms? No. Can we factor? No. What can we do? Catherine?
Divide by sine
Well, it's not an equation. So that what you're suggesting, Catherine, is if I have something like 2 plus 3, just deciding I'm gonna divide everything by 7. Well, you can't really do that, right? You can if it's equals, then you can do it. But, no, so that's a thought. Why were you thinking to do that?
Well, because tan equals sine over cosine.
Stop right there. Let's start with that thought. She says, look, I know that tangent is sine over cosine. So I am multiplying these two things together. Sine times tangent. That's sine times sine over cosine. Now, it would make me happier if something canceled here. It doesn't. What does this make when I multiply it together? What's sine times sine? What's 1 times cosine? There you go. That's what it makes. Now I still have an addition problem, but now, instead of adding that kind of stuff, now I'm adding 2 fractions, aren't I? And what do I do when I add fractions? And what would my common denominator be?
Cosine plus 1.
Actually, it would be just cosine. Because it's cosine times 1. Remember, you multiply your common denominator. So my common denominator is going to be just cosine. This one already has it, so don't be messing with that one. This one, we're going to have to multiply by a cosine. Now, do they both have the same denominator? Yes. My numerator is sine squared plus, what's this?
Cosine squared.
Oh my gosh. What's sine squared plus cosine squared? 1 over my cosine still, right? And this is like the 3rd time today, or 4th. What's 1 over cosine? So, Catherine, your gut feeling was right on target. Change that tangent into sine over cosine. And then we just did arithmetic, multiplied these together, got a common denominator, got our 1, and everything was perfect. All right, let's do exactly the same thing with number 8, and then we'll be done for the day. All right, so what do you think we're going to do with number 8? We have cotangent sine plus tangent cosine. So use Catherine's idea. She got her hand up again. What?
Could you cancel the tangent and the cotangent?
Now they're being added.
Okay.
If they were being multiplied, you absolutely could, because they're reciprocals, they're gonna cancel, but you can't when they're added,
Okay.
okay? What can we do with cotangent though? What do we know about cotangent?
It's 1 over tangent.
Well, it's the reciprocal of the tangent. And what's tangent? Sine over cosine. So what is cotangent going to be? Cosine over sine. So I'm gonna make this cosine over sine. Now this is a multiply right here. So that's times sine over 1, regular sine, plus, what's tangent? Sine over cosine, times regular cosine. Well, let's look right here. This is a fraction being times by another fraction. Anything happening in between my hands there?
Sine cancel.
Signs cancel, and what are we left with? Just cosine. Perfect. Plus, all right, now look between these hands. What happens? Cosine cancel, and I'm left with just sine. Now, don't get carried away. This is not 1. Why not?
Because it's not squared.
They're not squared. It's only 1 if they're squared. So that's the answer. Remember, our job was to simplify. Doesn't this look a little nicer than that looked? Yeah. This is your final answer. Okay? All right, we'll keep practicing, and I do have another practice sheet. I'll have to find that for you. And I will see you on Monday. No. Yes.
Yes.
See you on Monday. I can't keep my day.